I'm Scott Hanselman. This is another episode of Hanselminutes. Today I have the pleasure of chatting with Ed Rogers. He's the founder and managing director of Bristol Braille. He's here to talk to me about the Canute Console Premium, which is a fantastic new product that is open source for folks that want to use Braille to talk to their computers. How are you, sir?
I'm very well, thank you, and thank you for having me on.
So this is kind of a funny connection, but I think that for sighted people, we have seen in movies a one-line tiny Braille single line of text, and we kind of assume that there's like sighted people who use computers the regular way, and then there's the Braille person that gets one line, it's very small, and there's nothing in between. But certainly, sight is a spectrum, and I was actually legally blind before I had my LASIK, and I relied on, and still sometimes rely on, zooming technology. How many people use Braille? Are they always completely profoundly blind, or is there a spectrum within that space?
I don't know exactly. It's very hard to get the figures of for around blindness in general, actually, but not least because everyone defines it slightly differently. For legally blind is different to what makes you totally blind for one application and what makes you totally blind in the case of something else. So you might never bother to read Braille if you have a pinprick vision, where you means you can always read print, even though you're definitely legally blind and wouldn't drive, for example. In Britain, the RNIB reckons it's somewhere over 20,000. So as a country of 65 million people, you can probably scale that. There are countries like India where there are significantly higher rates of blindness because of certain diseases. And when it comes to who reads Braille, there was a real worry about 15 years ago that the answer is less and less people read Braille, regardless of how many. It's just less than 10 years ago, which was less than 20 years ago, and so on. There was a figure, I think, the National Federation of the Blind in America had, which was that in the 50s, 50% of blind school children learned Braille, and now it's more like 1 in 10. Please don't quote me on those. That could be off by a decade or so, but it certainly entered into a decline. And then there's been a lot of projects like ours taking technological solutions to that to try and patch up some of the vast gaps in what you can actually use Braille for. Because all very well saying, but we ought to make Braille more available so that people can learn it. But what do you then use it for in your real life? And there have been lots of projects taking the more human approach, which is to encourage people to meet up and learn off each other, as opposed to learn from institutions and so on, which is certainly great. But that when suddenly the institution loses its funding or something, then the community can just disappear, which happened over the pandemic in some cases. And you get a lot of
feeling that this is largely screen reader technology that has caused Braille to fall off. The idea that screen readers, and I've seen, I think I've had a number of blind developers on the show, and most of them have incredibly fast talking computer words. It's going in there. It's like 5 times 10x speed, and that's how they function. But I feel like if you were sitting at a Starbucks, it might be quite challenging. You can't really have situational awareness if you have someone yapping in your ear.
Oh yeah, there are limitations to what you can do with screen readers. Spelling, grammar, numeracy are much harder in most cases, and that's because a screen reader doesn't do something for a blind person that it couldn't also do for a sighted person. So having something read to you in a computerized voice, if you are blind, it's not the equivalent experience of reading print if you're sighted.
Well, that's a great point. Like an audiobook is not the same.
Braille.
Yeah, that's a great point.
But I should note, and you're right that it is, regardless of the point I'm about to make, which is that actually technically they're highly complementary, but regardless of that, there is certainly a lot of people who immediately respond by saying, surely technology and therefore text-to-speech has made Braille redundant, not quite realizing often that Braille is a form of technology, and in fact, a electromechanical form of technology where you have 1,000 pins moving up and down with almost total accuracy is an extremely advanced form of technology. And Braille itself is significantly younger than print. It is technology, but Yeah, there is a sense that other forms of digital technology have undermined Braille, and therefore maybe we don't need to bother teaching it because it's a bit easier to just have something read to you. The question is, would you want your child to have the opportunity to read print and therefore Braille, or just have them spoken to by a computer? So the point about it being complementary is that in the modern world, it's not that much use having everything in paper. You need Braille displays, which is what we build, and Braille displays have to be fed by something and have to be fed by a computer. And those are, unless you have a totally integrated device, we have some integrated devices, but unless you have a totally integrated device, that takes a screen reader. So the screen reader speaks, but the screen reader also drives the Braille display. So the screen reader itself is what enables digital Braille.
You know, as you say that, it kind of immediately kind of becomes obvious to me, but it wasn't immediately obvious. You just connected two things. You're absolutely right, because the screen has in programming, we'd call it like a DOM, an object model that describes like a calculator. And the DOM has to decide, if I'm going to present a calculator on the screen to a Braille display, what does someone want to see? Do they want to see a grid of 1 through 9 organized in a square? Or do they want to see the numbers 1 through 9 in a row? It could be preference, it could be convention, who knows?
The answer to that particular one, of course, has been until we invented the multiline Braille display, it had to be a line regardless of what it's supposed to be. But yes, it's the same. The data is in the same place, and it needs to be served both through TTS and to a Braille display, and that is usually done with the same screen reader. That you some people might switch, but going off on a screen reader tangent, because it is interesting. There are different ways that that's done, and to use JAWS, NVDA, and BRLTTY as 3 different examples. JAWS has been around for a while, and that's the commercial one. And that, I believe, I'm not an expert in this stuff, because it predates a lot of the more useful APIs on systems like Windows. It would do a lot of work getting stuff off the video feed, whereas something like NVDA relies very much on that DOM model and on the accessibility that is built into applications. And then you have BRLTTY, which is straightforwardly an evolution of running from the command line. So it just reads text in the console and it doesn't require any accessibility features per se. It shows you what's on the console.
Okay, so let's reset for folks that are listening, because a lot of folks are hearing this audibly and can't see you and can't see the Canute console premium behind you on your desk. So Braille is this writing system that blind and visually impaired folks use. It's six dots. Each letter is 6 dots. It's 3 dots in 2 columns, so 2 columns of 3 dots each. You're a sighted person. What caused you to feel like this is a problem that you are and your group is ready to solve?
If you dwell on that for a minute, it's 6 dots and it represents the entire alphabet, every alphabet, pretty much every alphabet in the world. There are some cases where no one's got around to it yet, but there's Tibetan Braille as an example, and music notation, and various other systems for computer science, for numbered-based work. And it's all the same 6 dots, and it's all spaced a tenth of an inch between each dot. It fits under the pad of your finger, and it was invented by a 15-year-old French boy 200 years ago. Isn't that incredible?
I mean, it makes me want to learn it, actually.
Exactly, and it's so brutally clean. There's no typefaces. Well, there is somewhat a typeface in the sense that some countries, like Japan, uses a slightly smaller Braille cell than some other countries, but not meaningfully any typefaces. And everything is arranged in a grid. It's just got this austere beauty to it, and it was I think the first binary, byte-based system, because it's a 6-bit byte. Numbers, for example, are represented with the first 10 letters of the alphabet with a hash sign put in front of it, or it's not literally a hash sign, but represented in text as a hash sign, and that's just very appealing. And then you put in the challenge, the engineering challenge of, okay, but those have got to be dots that are a 20th of an inch high, perfectly rounded. They are a tenth of an inch between each dot. You need to have hundreds of those. In the case of the Canute Scientific behind me, you need to have 2,160 of those dots. They need to move up and down with reasonable speed and almost total accuracy 100,000 times. Go.
So this is a fun engineering problem.
It's a fun engineering problem, but and then you add on the fact that people are being charged sometimes tens of thousands of dollars for this stuff. And you think, come on, surely there's something. The answer is, there is a lot of somethings, and they're all really hard to do.
Historically, I have seen those one line, like 40 character, maybe 60, maybe 80 single lines. It's just it's a black strip. And they move and they hop up and down. Are they all mechanical? Like, there's lots of fascinating things happening in the haptic space and the tactile space. Are you physically moving 360 refreshable pin cells up and down mechanically? Or are there new ways to think about how I could make a pip or a dot go up and be felt and then retract?
They're all mechanical. I suppose you're asking about deformation of a surface as a potential option.
I guess that would be a way to look at it.
Yeah, the problem with that is that is a much harder challenge than mechanical, because the deformation then would have to deform into a perfect rounded dot, at which point you might as well have a pin.
And I assume people have an expectation. They have an expectation of what it should feel like.
Yeah, I mean, if your manufacturing is well, everyone's manufacturing is slightly different. So ours is very hard Braille. It's somewhat sharp if you press hard on it. A lot of people like it, but everyone's is slightly different. So the idea that it's possible to create a deformable surface which complies to Braille is an unnerving idea. It's probably not the best place to start.
Okay. I'm just kind of wondering if there's like an e-ink display for Braille, in the sense of like LCDs have a purpose, and then e-ink came out, and we as sighted people said, oh, this is delightful for reading. Is there some other thinking or creativity around how one could deform a...
If you go back to the pin technology, there are a number of different ways, and those ones you're talking about, which have been around since the 80s or something, that's a piezoelectric cell. So each one of those has a strip of every one of those dots has a strip about 4 inches long, I think, of a piezoelectric, which is a ceramic material. When you pass a very high voltage, very low current through it, it warps very slightly. It moves a pin up and down. It doesn't hold much. You can press it back down again. It's not got much force, but that works. It works very well. It's just that those piezoelectric strips are very expensive. Our technology actually doesn't have any pins at all. So we have 2,160 dots, but no pins at all. We only have 1,000 moving parts in the whole device, because we use a series of octagons. And so we only have 100 motors in there, and 2 of those are vibration motors we don't actually tend to use. So 98 motors, and those are, so we use a 720 octagons, which you spin into new positions, and the pins are actually, well, there are no pins. The dots are embossed around the outside of these octagons. So we essentially remove the part of the Braille display which causes the most cost, which is individually actuating 6 different dots for each cell, and we only have 98 actuators and a lot of little clockwork parts, and we build that in Britain, in our own workshop. I'm here now. It's about 700 square feet, and we build the world's most affordable Braille cell technology. It's about £12. That's what, $17 per Braille cell, which doesn't sound that little, but when you think how much it costs to build these and to ship them around, and we are, as I should emphasize, we're a very small company. So we're really the minnow swimming with sharks here, and enjoying it.
So you're saying that a Braille workstation with one line might cost thousands of dollars. I mean, it might be like used car money. And you've got 9 times the data, 9 times the lines, and and you also have a screen. It's worth noting you also have a high contrast 13-inch monitor, because not everyone has full, blindness. They may want that top screen for less than.
If whoever you are, you're going to work with a sighted person, and
that's touche.
So on the Canute Scientific and on the Canute console before that, the Canute console is a modular design. The Canute Scientific is the one that we're just releasing, and they're both very similar in their outlook, but the way we build them with the open source ethos and so on. But they both have a monitor, which, as you say, is 13 inches in high contrast, which synchronizes exactly the same data to the Braille display, which is different. So normally you have a Braille display, and either that is reading a corner of a visual screen, or it has no visual screen, and you can plug one in, but you always get more data visually, or none at all, than you get in Braille. But we've designed something from scratch, which runs mostly in the command line, although you can open desktop applications now. which is designed to make tables, charts, diagrams even, and of course prose and programming and so on, have exactly the same layout. Because when you were saying people are perhaps familiar with the sight of a single line Braille display, those are great. They have been very important. But text is not actually a linear medium. It has structure. Especially tables are the easiest way of describing that, of persuading people of that, because tables obviously have structure. And if you only present tabular data horizontally, one line at a time, then that rather excludes all the possibilities that you might be looking at data which is vertical or at a diagonal. A lot of table data is presented diagonally, which is something you're not going to get however you mess around with that data. But also just prose. Prose is not as linear as the TXT format would make you think. It's how stuff lines up, top over tail. It informs how we read stuff, how the headings interact with the rest of it.
I mean, certainly a simplistic, but an example that just clicked for me would be poetry, which you might want to move forward and backwards within, or explore a line and then move forward and then go, I want to look at that line again. Before, they would have to back up in their linear single line, and now they can just move their hands up a line.
And very similarly, sheet music, when you might have something for one hand on one line and another hand on the other line, and you might have the vocals underneath that. But of course you can't if you don't have multiple lines. So we're really we created our first display based off this technology, the whirring octagonal discs, if you like, which is very different and almost an entirely different category to normal Braille displays. We created that in 2019, 2020 and released it as an ebook reader, purely for the pleasure of reading. And then we moved into making workstations so that people can use the open source software that we've been building to solve their own problems and share that with other people. And problems being something like, I want to be an astrophysicist. I have all the talent and the enthusiasm for that, but I keep getting given these inaccessible things, and I need the tools to solve my own problems. And then I want to present it to my sighted colleagues in a way where we can both interact with it equally. And that's where the Canute Scientific and the Canute Console before that came from.
These discs, I want to make sure that I can visualize this, and we can certainly go online and learn more about it. There's both the Canute Scientific and all the Bristol Braille main site has all of this, as well as videos explaining it. But is it like a die or a dice that is rotating, or is it a disc in a single plane that is rotating in a circle?
It's rotating in a single plane. So it's 80 octagons on one bar, one steel bar, and those are spun, and that gives you 40 characters, 2 octagons for one Braille cell. If you think of a Braille character, as you said, 6 dots in 2 columns, but that's actually 2 columns of 3 dots, 2, 4, 8 possible combinations for each half a Braille cell. Therefore, it fits around an octagon.
That is very clever. And the thing that I think is really significant, and I think that that all my listeners, sighted or otherwise, will appreciate, is that it is delightfully repairable. Like, you believe very strongly in the right to repair field replaceable parts. Like, if you're blind and your thing breaks, you want to be able to get it fixed. You don't have to ship it off and wait 6 to 8 weeks or longer for your lifeline to be repaired. It should be open source. It should be repairable. It shouldn't be a big giant company controls this and only one person knows how to fix it.
Well, we released our first product, the Canute 360, very much in the conventional way that you do. It was a product, and if you need it, we hope it won't break. But if it does, we'll repair it for you. Don't worry about it. And it has a warranty. If it breaks after your warranty, in principle, you'll have to come and get another one or pay us. In practice, what ended up happening was we just fixed everyone's machines, because each of these machines took a very long time to build, and we sweat, literal blood and sweat and tears would go into this, and neither of those three was an exaggeration. We wanted all these machines to work, and people would say, "Oh, I kept getting stuck in customs. I can't even get it back from the Netherlands to Britain. Can I possibly fix it here? My father's pretty good at this. Him and I could work on it together. And we're, all right, we'll send you our repair manual. So we never formalized that until the Canute Scientific came about. I mean, we're going to really formalize it. We've redesigned the chassis so it's all can be taken apart. It is not a simple task. It's not something you should do for fun. This is not like one of those framework laptops where it's designed to be popped apart and change it up. It's like, think of it like a car. You spend a lot of money on this. You have the right to try and fix that. If your carburetor gets clogged up, you have the right to sort that thing out. Even though it's not simple. There's 1,000 moving parts. It's not simple, but you have the right to do it, and we will help you do that. Yeah. And importantly, much like with cars, where you have the most complex part is the engine, and the engine in a modern car can run for 150,000 miles or more. But people have to replace their cars far more often than that because all the electrics keep going wrong or go out of date, and and all of this stuff. So I really dislike that. The Braille display is the expensive part of this, and it's the part which is hopefully unchanging. What's not is the electronics underneath it, the Raspberry Pi 5, which controls that. We have ports on here which are not only modular in the sense of we'll sell you a modular replacement in the future. No, they're literally hubs which you can unplug and buy another one off Amazon if you wanted to and stick that one on instead. So it's really as much as we can possibly make it. The person who owns it.
So you said a Raspberry Pi. So in the past, you would use embedded operating systems, but you're using open source hardware to make this happen. And have there been any challenges with that, or did it just work?
Actually, in the past, we used the Raspberry Pi 2. We've got two in here. We've got the Raspberry Pi Zero controlling the built-in operating system on the display itself. And then we've got a Pi 5 on the Scientific, which is for doing the applications. That's a hangover just because the Pi Zeros are so fabulously cheap. They're a great way of building embedded systems. No, it's obviously, I say obviously, but to everyone that works with systems, it's easier to use an open system. It continues to be a mystery to me why people continue to use like Android 8 or something as the basis of extremely expensive equipment. And then you speak to the manufacturer about, can we upgrade this at some point? Like, oh, we're trying. Well, why didn't you just use Debian? You're not running apps.
Yeah.
So, we're just running the Raspberry Pi version of Debian on this, and there's problems, but none of the problems are to do with the operating system. That's a solved problem. People keep making it a problem by locking it down. If you don't lock it down, and the problem I think companies have is they feel like if they're open, someone's going to go and eat their supper. It's really hard building Braille displays. No one really wants to do it. No one's going to steal our stuff that easily. And if anyone steals the Canute design and starts making it cheaper than us, we'll probably be their best customer. We'll badge it and sell it on again, It's better to be open on this stuff because when you have a richer ecosystem which solves your problems faster from a purely personal, selfish point of view.
Yeah, that's such a positive and reasonable, this is why technology is supposed to exist. It's such a reasonable perspective. Like, oh no, someone made our product 10 times cheaper and now more blind people get a great experience, right? That would be fantastic. That would be, you might be like, oh shoot, our little company is going to change, but more blind people get this available. Like I mentioned it before we started recording that I use an open source artificial pancreas. So I use open source software and we use commercial hardware, and we're working on things like open source insulin pumps. And I'm always thinking to myself, man, I'm in the Northern Hemisphere. I am so lucky to have these things available. And there's so many diabetics that don't have these. So from your perspective, I can only assume that you're thinking every single blind person should have the option to have one of these in their lives. We just need to figure out how to get them made and get them to them if they want them.
Yeah, I mean, don't get me wrong. If someone steals our stuff, it would upset me deeply because it's upset them because they stole it. They could have just asked them.
Well, the principle of the thing,
right?
Yeah.
But I am actually very proud that we build it as affordably as it can be built, given the capital we have here in Britain. And you don't need to try and find someone who will cut costs in order to build cheaper equipment. Sometimes when you're working with, I don't know, paying someone a reasonable hourly rate of over
a living
£10
wage
or whatever, a living wage is not the major problem that keeps the cost of complex equipment. It's the support, it's the designing it better, and a lot of that stuff can be ameliorated in other ways.
Yeah, that's a great point. I'm curious also, I'm a coder, of course, and I spend a lot of time now doing coding with LLMs, and I use a lot of voice. And you mentioned that a lot of blind folks work at a terminal. A terminal lends itself, of course, to a great experience. Have you had any feedback that a 9-row larger Braille display plus a coding LLM plus a terminal kind of changes the experience for blind developers? Because this feels like the perfect device for a blind developer.
The console, which is the sister product of this, the one that came before it, the console is a dock where you dock the Braille you dock our Canute Braille e-reader, which I said was the product released in 2019, into this to make it into a workstation. Then we redesigned it to be more open, literally openable in the sense of it can be dismantled, and then it became the Scientific. The console was so named because it was designed for developers working in the command line, and it is a really nice environment. It's especially a nicer environment for working with a LLM than it is for working in code that you wrote yourself, of course. But it's anything where you get to have the context of seeing the full function. It has obvious advantages. You don't have to build that model up in your head, and it is especially difficult with Python and languages which insist upon certain forms of white space, because that means you can't, as a developer, decide to strip all the white space out because it works better on your Braille display, and then, or you can't get away with doing it your way as a Braille reader that doesn't need indentation. It won't run. So
suddenly I started thinking about YAML on a Braille display would be like the ultimate challenge.
This application behind us, this is the launcher menu, which is itself simply a YAML file, which is piped to one of our functions. So we've built a whole set of functions which enable someone to build applications just by writing YAML files. So you can write a YAML file for a grid, for a diagram, for a table, or for a menu, of course, and forms. I say a table. I don't think you do it for a table, and of course you don't necessarily want to write your own YAML files. You might want to pipe some CSV to that so you can generate the YAML from that. But the idea is we want people to throw together solutions very quickly. And that's where we have to find our strength, because we are a small organization. What we're hoping is we want to find mainstream partners who want to roll out blind accessible makerspaces. That's the reason we're calling it the Scientific. I've got a 40 pin out here on the side of this one, because we want to be plugging in sensors and oscilloscopes and robotic arms and so on. We 3D print many of the components, and we've been working with the Clovernook Center in Ohio to investigate letting 3D printing be more accessible. But that's what I'm really hoping for, is to meet organizations who are mainstream in terms of they're not from our industry, but they want to experiment with making their spaces accessible, and we can work together, because there is a whole community of blind people who are already experimenting with this and can work so fast if given the tools and the space to do it in.
How does the word get out? Is it word of mouth? Is it podcasts? Is it YouTube's? Because if I am blind, and I'd love to hear from listeners, and I heard about this, I need this now. Like in my diabetes community, people hear about it by word of mouth. And they go, "Oh, this is what I need." Or you remember that wheelchair that would go from 4 wheels to 2, and it would allow people in a wheelchair to like stand on their tippy toes because or go upstairs. Like as soon as the word comes out about that, it's like, oh, I must have this in my life. Do people learn about Bristol Braille and then just immediately reach out? Have you had amazing stories of enthusiastic people who are like, "This is it. I need it"?
Yeah, I had a call yesterday at 2 a.m. local time for the person calling. It was perfectly reasonable my time. He was just very enthused. He'd heard us on a podcast, and that was really great. We talked, amongst other things, at great length about Niki Lauda. But you go off on tangents. We won't go into the Niki Lauda conversation right now. Formula One champion, for those who don't know. And now, but I hope whenever we talk about it, I need to get around to telling you what the differences that are disadvantageous about our technology as well, because I hope that when we talk about it, it comes across very clearly that we aren't proposing that we're better than the other multi-line displays, which might be more expensive but have their own features. We're proposing that we have a different philosophy based around empowering people to own their own technology, even if sometimes the technology you own is kind of clunkier, chunkier, and it makes a fun noise when it refreshes and so on and so forth. It is yours, and you could have afforded it. And that honesty does get us some people coming up and just having very long conversations. And we then, if they buy, we build custom applications for each of those customers that buys into our premium, at least. And for someone who hasn't bought a premium, we certainly still listen to what they want and try and build it as soon as we can. But the short answer to how most people find out this is events. So it won't really be that surprising to know that Braille displays are something that you tend to want to touch to get a real feel for. So we try and do as many events as we can. We do something like two a month.
Oh wow!
And when we can, but of course that becomes difficult for a very small company when these events are all over the world.
Yeah, indeed. You're sighted, but I assume you read Braille, and what does that feel like?
Well, you can read Braille and you can see Braille. So you can read Braille visually.
Can see it too. You're right.
Yeah. And it will depend. For me, I tend to do both because reading is easier to get a vague idea for where to look.
Right.
Because I'm highly sighted dependent, if you like, sight dependent. But it's very hard to pick out dot errors. So you use your finger to spot whether there's a mistake. Because of course, one of the main purposes of me reading Braille is quality checking the devices and sending it back to have a rib replaced. That's what we call our a column of Braille. That's our smallest module. Because a motor is a bit laggy or something like that. So that you really have to rely on both sight and touch to do that. So that as a sighted person, it really depends on the device you're reading. And ours is very easy to touch read, whether you're sighted or not. And it's been made hard because, literally the Braille dots are hard, which they're much softer on other devices, because we worked a lot with people who were diabetic in our early years, and that causes neuropathy, which means that you may have learnt Braille, but haven't really been getting on with it much these days because it's not quite as easy anymore.
Yeah, diabetes is the leading cause of blindness, and certainly the thing that is awful about it is that your fingers go numb as well. So yes, hard Braille would be far easier for a blind person who has become blind because of diabetes. Does your brain click and change in some way when you start, like when you're learning a quote unquote foreign language? You translate in your head, and then at some point it clicks. So whether you're reading Braille sighted or whether you're feeling it, it seems like Americans are very fascinated with like learning like American Sign Language. Like it's always a good idea to know a little bit of light sign language. I know there's BSL, there's ASL over here. Is there any value in a sighted developer or a sighted person thinking about Braille? Because I'm thinking out loud here, but if a blind person and a sighted person are equally talented, what tooling is unfairly slowing the blind person down, the blind developer, or the blind knowledge worker down? And what could I do as a sighted person to make tools that can interface with something like a Canute Scientific to eliminate that gap?
Well, the second half of that first, then the second half was about the gap. And that depends on whether the data is inherently visual or not. Because if the data is inherently visual, then there is an inherent disadvantage if you're asking someone to look at a JPEG of a family photo. There's a lot of detail. There's mountains that go down to ridiculously level of grain in the background of that. There are means of doing that through tactile graphics, but they are not equal. They're not an equal experience. They're different. They're not necessarily worse, but they are much less detailed. Braille, though, is equal in the sense that someone can learn to read as fast. It's been measured in the sense people have done studies, and the way that the data is remembered, the sort of proactivity of remembering it when you read with Braille or print is about the same, and so on and so forth. So it is identical essentially for practical purposes. So if your data is textual or numeric, the most important thing is is to note that actually underlying this is textual and numeric data, and not to make it unnecessarily to bake in some visuals. So if you're showing someone a chart, give them the underlying data so that they can read the data and possibly, if they have a Canute Scientific, generate their own chart from that data in a way that works for them. So that would be what I would say. I've forgotten the first.
Well, I think how does one's brain click? Like, I feel like when I did ASL, we taught our kids baby sign language. So when the children can't speak for the first 2 or 3 years of their life, you can communicate with them quite effectively with sign language. And when you interact with a deaf customer, when I was doing, working in a restaurant, I found that to be very helpful. I could see less useful reasons for me to know Braille. But you, as a sighted person, being able to know Braille, I'm wondering how that kind of clicked, if it activated the foreign language part of your brain or what happened.
Yeah. It doesn't, because Braille is everywhere around the world, is in that language. So it's a different code for the language. The simplest way of saying it is there's a different alphabet for the same language. It's not literally just a different alphabet, because there are contractions in English Braille. But in many countries, there are no contractions. So contractions, things like the word "the" is a single character. So in many languages, it really is just a different take on the alphabet, so that you don't necessarily get that click, if you like. But when it comes to learning the contractions, or that sense of being able to feel
the fluency of information flowing into your fingers rather than into your eyes.
Right. I have passed the first one sometimes and have since regressed. But when you're picking up the contractions, that is essentially the same as picking up shorthand in that kind of sense. If you can imagine that, or in a sense, like learning a programming language, which is not the same as learning French, for example, but it's not a million miles away. I've never experienced, of course, becoming fluent in touch reading. It does get harder the older you are, and at some point after your mid-20s, it takes more work. And if you're sighted, you have to be very dedicated to develop to the point where you're fluent. But you can, it can be observed that there is a point at which someone reads at the same speed in Braille as they are reading, as a sighted person reads visually. And if you observe that, it's clear they are not feeling, they are not consciously checking the dots. The dots are just happening, and they might scoot the hand back and forth, and they might use a different hand. So that is clearly the click has happened, if you like. And the click, it's not really my place to say, but I think that you would therefore say that it is in the sensation rather than in the code itself, which is not, strictly speaking, a language.
Yeah, I think when the Canute Scientific and Braille disappears and it just simply the information flows, that's when the blind person really is unlocked and unleashed and able to do everything that they want to do. Yeah. So folks can learn more at bristolbraille.org. We'll include links in the show notes. The website is the primary place for folks to interact. If someone wants to partner with you, if someone wants to spend time with you, if they want to work with you on a makerspace or something like that, they can just reach out from the website.
Yeah, and we've got US, UK, and WhatsApp for getting in contact with, or just email us. But you can also, if you check our diary, because if we happen to be in a city near you, you might as well pop over.
Yeah, absolutely. And then they can go and see the Canute Scientific pre-launch. There's an initial limited batch run happening, and then you can check out the shop and contact them. Thank you so much, Ed Rogers, for chatting with me today.
Thank you. It's been a pleasure.
This has been another episode of Hanselminutes, and we'll see you again next week.